Hello and welcome to TidyX episode 51. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. And you can find the screencast of TidyX on Twitter at tidy_explained. You can hit us up on Gmail, tidy.explained@gmail. Or you could comment on the YouTube page, or, which we'll talk about at the end of the episode, you can open an issue on the GitHub repo. We'll talk about that after we go.
I can just quickly.
Episode.
I can show the website quickly. We can go into more detail.
Let's do it now.
Let's do it now. All right. So what we're thinking is a great way, because we put our code available on GitHub. So you can go to github.com/thebioengineer/tidyx, and you can see all the code that has been used in any TidyX. We post summaries of every episode, links to everything. So everything is available for folks to look at. But what we'd like you to do is, if you have an idea for us that you'd like us to look into and potentially make an episode about, we want you to start opening issues for us. So you can go into this issues tab here, click new issue, type I don't know, we were talking before we recorded here about potentially doing models about probability of hit given a throw type for baseball. So you can then submit new issue, and then we can see it.
You can show. Well, you're not showing your screen though.
Sorry, you can't see this. They can see this.
I can't see. Oh, they can see it.
Yeah, I'm capturing the screen, but
got it.
I guess you can't see it. But yeah, so now I've opened a new issue. So now we have a running tally of things that we could potentially cover, and so we want to hear from you what you want us to cover.
Yeah,
because we're having a lot of fun.
We'll also be able to see our
ideas.
We're gonna keep our own issues. Not issues. We're going to keep our own thoughts about, like, ooh, we could do this for an episode. We could do that for an episode. That way we have kind of a running list of potential things. So you'll be able to see what we're thinking. You can add what you're thinking, and then we'll strike a middle ground somewhere.
You can comment on the issue. If you see an idea that you're like, I'm really excited about, comment on it. Tell us. That'll raise it to our awareness that there's excitement around that idea. Yeah. So we can work on that more, because we're all busy. We're constantly trying to come up with content for y'all. So this will help drive us towards stuff that you're interested in. Yeah. All right. Let's start episode 51 now.
Yeah.
What are we doing today, Patrick?
So, today what we're going to do is we're going to use Shiny, as we've done many times in the past. And we're actually going to, instead of just talking about visualizing data in an interactive way in Shiny, we're actually going to embed a statistical model into Shiny and allow the users to define the parameters of that model, and then the visualization shows us the output of that model. So we haven't done this before. We've done models and we've done Shiny, but we've never put them together to allow the users to specify parameters and get an outcome. So that's what we're going to do today.
Yeah. All right. Yes. Yeah. So we're going to start off today loading a couple packages. So tidyverse for our data manipulation needs, randomforest for us to do some model predictions, and Shiny to do the data the actual visualization and interactivity and all the funness around that. Yeah. So we have a simple example on linear regression starting at line 8, but we're not really going to go over that. We're going to go over a slightly more complicated version. But this is here if you're interested in looking at it more and trying to get just a more simple understanding of the process before hopping over to a more complicated model.
Can you just scroll down that one just a second? I want to make sure. Hit pause. Oh, wait. Scroll up. I did have an error in this code. In the predict, it should say fit_LM. And then it should do the same inside of the Shiny app before you collapse this down. Go down, predict. There. Okay.
All right. So
now collapse.
All right. Good to know. Oh, sorry. So there's a cool feature in RStudio if you're using RStudio, which it's a great IDE if you're not. If you can write comments in your R script, and if you do 4 of the hashtags or pound signs in a row, it'll create a chunk for you. So now what you can do is, if you've got all this code that you really don't want to be looking at, boom. Collapse it. If you have to be doing the four pound symbols or hashtags, but now it'll collapse it and we don't have to look at it anymore.
So what would the one below that do? Because there's 1, 2, 3, 4, 5 hashtags.
Same thing.
It'll collapse. Okay.
But you can also see here. So because you had 5 hashtags, it's seeing it as a child. So we can move it up a level there,
yes.
And so now they're at the same level.
Yep. There you go.
So it's kind of like our Markdown, where the more hashtags you have after that, it's kind of headers going down.
Yeah.
All right. But now let's get started again on episode 51. We're going to also load in a library called palmerpenguins. This is a package that contains data around palmerpenguins, and it's a great alternative to Iris. It's a newer package, so you haven't seen it a million times.
Yep.
And
we used it.
Yeah,
we did like stats plotting of this in one of the episodes a long time ago.
Yes. Yeah. No, that was a fun episode.
Yeah.
To work on. But yes, let's get into palmerpenguins. So let's take a quick head of this. All right, so the data that's in palmerpenguins is penguins, and it contains some information about penguins that they've... Actually, let's quickly bring up the help page. So it's size measurements for adult foraging penguins near Palmer Station, Antarctica. It includes measurements for penguin species, island in Palmer Archipelago, and size of flipper, body, bill, and sex. It's a subset of penguins raw. So we have this data set here. So we got species, island, bill, length, depth, flipper length, mass, sex, year. What are we going to do with this? What could we do with this?
Well, we can build a simple model to try and classify the type of penguin based on the features of their body size. So we pulled in the data. We did do a little thing up at the top there where we dropped the NAs. The drop NA is going to get rid of any row, right? So this is a row-wise deletion. Any row that has an NA anywhere, it's going to omit that row. We could have done things like impute, and we've talked about imputation before, but we're just going to go with drop NA to keep it simple. There's enough data in here to have fun with anyway. So we drop the NAs, and we're going to build a simple kind of random forest classifier. We talked about random forest more in depth in the coffee episode, which was 42?
No, it was here. Let me quickly search this random. And you can also search our GitHub page for any topic that we've covered in the past. You can just search it. So it was episode 18.
18. Oh, wow. Okay. Long time ago.
Yeah.
So we've talked about random forest before, but basically what we're going to use this random forest model for is to spit out a probability of the species being one of those 3 that are in our data set.
The Adelie, the gentoo, and
Adelie, and the chinstrap. Okay. So we're basically going to call random forest, and species is going to be our outcome variable, our dependent variable of interest, and we're going to try and forecast species based on bill length, bill depth, flipper length, and body mass, and we're calling this on the data penguins data set, which we've dropped the NAs from. So we run that model. It runs very fast. We hit fit RF, and that gives us a quick and dirty confusion matrix. Just note, we didn't do anything up front like set out a test set and a validation set and have a training set. The idea here wasn't to build the best model ever and really talk about model validation. It was more just to create a simple model that we could then put into our Shiny app in order to create a visual of based on a user interface. So we get a cool little confusion matrix, and that tells us the model error was about 2.7%.
It's pretty solid.
Pretty good, and we can see where the model messed up, etc. So before we throw this into a Shiny app, I wanted to wrap my head around what kind of code am I going to need in the server in order to do this. So I created a new data frame with just some fake values for each of the features in our model, and so we have this little data frame there, one row of data, and basically what we need is a column that projects the species. So we're going to predict fit rf, new data is the new data frame, and the type I set here to probability. If we remove probability, which we could do in a second, what we are going to get is the highest value predicted, right? So you're going to see there's going to be a probability that it's one of those three penguins, whichever had the highest probability of being the penguin forecasted. If we remove type probability, we get just the highest projection. In this case, we put in type probability because what we want to do is we want to be able to visualize the probability that it's one of those three penguins. So now we have our predictions, and what we want to do is we want to take this and put it into basically a data frame that we can then visualize within our Shiny app. So this is what the data frame in our server is going to look like that we're going to use to visualize our bar chart.
So let's quickly go through like what is actually happening here.
Yeah, so we take our predicted species, which again was this little data frame here with the probabilities of the features leading to one of those three penguins. And I just turn it into a data frame within Tidyverse. So I put some pipes in, I call data frame. That's going to just extract out that bit there. So basically it took it and turned it into a data frame. And then I'm going to pivot this longer. So I'm going to say columns equal everything. So right now, each of those penguin names is a column. I'm going to say take all of those columns and I'm going to pivot them longer, and I'm going to put the names of those columns to a single column called penguin type. And then the values within each of those columns are going to be called probability, which is the probability of the features that we specified being one of these three penguin types. So that leads us to a cool data frame that is easy to visualize within ggplot. So why don't you take them through the user interface, because you did something cool here to make this really pretty for the user. So
sure.
Let me go through that.
Yeah, so let's go through this. So as we've covered in past TidyX episodes, the Shiny is built out of two different components. There is the UI component and there's the server component. And the UI component is, what do we see? How are you build it up in the way that you expect people to interact with it. And so it starts out with fluid page. So fluid page means that things are going to be able to move around fluidly. We're going to add a header panel. So this will be a header for the very top of our Shiny app, and it'll appear across everything for us. And we're going to put in there the text penguin probability. So at the very top of our app, it'll just have the words penguin probability for us. Now, when we were going through this and discussing, we're like, okay, well, how would we want the users to interact with it? A lot of people, when they build Shiny apps, use the side panel and main panel infrastructure that comes with Shiny. But we decided, no, what we want to do is make it a little bit more interesting. So we're using the function fluid row. And so fluid row is going to be it's defining a basically linear chunk of elements that we're going to be adding into our Shiny app. And then we're going to start adding content in there. And if you recall back to the Shiny episodes, the width of a Shiny app is broken up into 12 segments. And so what we can do here is we can call the function column. So now it's going to cut that 12 segments into a column that's width 3, so 1/4 of the width, and we're going to drop in a Shiny element in there. So column, we're going to then drop in a slider input where we then start creating all our Shiny decision-making abilities. So the input ID is bill_length_L or mm, which is how we access this data in our server side. The label, so this will be the text that shows up above our, the function we're going to use here is a slider input. So this is like a slider that you're able to click and drag left and right. It's very interactive and understandable. And I think everybody, when you see a slider input, you're like, I know what I'm supposed to do with this.
Slider input.
But yeah, so input ID is bill length mm, so we'll access that on our server side. The label, so the text that appears above our slider, is select bill length mm. And then we set the mid and the max values. So this is how far, if you take the slider and go all the way to the left, what is the value? And if you take the slider and go all the way to the right, what is the value? And in this situation here, we decided that we were going to limit that by the maximum minimum values in our actual data set. So this is assuming that the sample from penguins is a representative sample, and there cannot be penguins that have a bill length that is smaller than the smallest penguin that we measure bill length, or larger than the largest penguin's bill length. In actuality and functionality, you might want to look at adding some padding around that. So at the minimum value, you might subtract. So this also requires some contextual knowledge. We're not zoologists. Surprise, surprise. We don't have the knowledge around what a reasonable penguin bill length is. That's why we went with these max and min values. But if you're a zoologist, you might have that contextual knowledge, or you can just add a little bit of padding around it. So for min, you can like subtract 10, and at max, you're like, oh, well, I mean, there we go. Now we have a little bit of fungibility or flexibility around this. But then we also have to identify the starting value. So what is going to be the value of the slider input when we start up our Shiny app? And we decided, let's just take the median of the bill length just as a starting point. Obviously, the users are going to be able to slide it around. This is just to get things going. So we've now done this for bill length and we're going to do the same concept 3 more times for bill depth flipper length and body mass G. So now we're going to have 4 elements laid out horizontally next to each other. So you've got 4 sliders with their column headers above there. And then underneath that, we're going to have a main panel. So this is where the main contents are going to go. We're going to set the width to be 12. That way it goes to the full width of our Shiny app. And then we're going to create a div. So this is important because if you want to make your content, or what I wanted to do is, because we've got these 4 nice headers at the very top, is I wanted to have that bar plot show up in the very middle, all nice and pretty like. And so in order to do that, we make the main panel width 12, so it goes the full width. We add a div. So this is an HTML element called a div, which is basically a box. And so I'm telling it, be the full width that it needs to be. Margins are auto, so it'll automatically shift the margins based on your web page size, and then text align equals center. And so what this will do is it'll take the content and center it inside of its div. So now when we add our plot output, which is the plot that we're going to be generating, the bar plot, and we're going to set the output ID bar plot inline equals true, so now it's going to be using a span. It's now centered that content, centered our bar plot in the actual viewer. So now when we go to run our Shiny app, it's going to look very nice, and everything can be centered and square and look like they were kind of a professional. So I don't know, whenever I'm working with Shiny apps, I tend to get very tied into the UI and like trying to make it look really nice. So I spent way too long trying to figure out this little chunk here. So hopefully you've now learned a little bit from me, so you don't have to spend as much time working on this.
I think you left the padding in on the first one, in the first slider input.
Oh,
yeah.
Good call.
The other thing is with that main panel, you set the width to 12 because main panel, Shiny always assumes that you're doing a sidebar panel and a main panel. And so it auto sets the sidebar panel to 4, and it auto sets the main panel to 8, right? That equates to our 12 units of Shiny width. So you do, to make this work, you specified width equals 12 to get away from the auto preset of 8.
Yep. Yeah. Exactly. So that is our UI. So what it visually is going to look like to folks. Yep. So now we get into the service. So this is the backend. This is where all the R code is going to chunk away on things and do stuff. Yep. And so the first thing here, so you use the server. It's a function. It's got inputs and outputs.
Yep.
The first thing we do is create a reactive. So this is where things are going to react to changes in our Shiny app UI to run and chunk based on their inputs. And so anytime an input updates, it'll update that.
Exactly.
In this case here. And so, Patrick, you want to take us through this one?
Yeah, this is actually the reason, the method to my madness of building the new data frame up above our Shiny app to see how this was going to work when we predict something and make, was that I could literally take that and paste it in here. And instead of having my preset values for bill length and bill depth and flipper length, all I do is I change those to the inputs that Ellis just specified in the user interface. So I'm basically saying input $, bill length is basically saying whatever the user inputs, that's going to be our bill length data for this new data frame. Whatever the input that the user specifies for bill depth is going to be our bill depth, our flipper length, and our body mass. And that's going to create the new data frame just like we did in my little example up above the UI. I literally copy and pasted this in. That's usually how I work when I do these things, to wrap my head around, like, what's it going to look like? I try and build it without being interactive first, and then I just kind of copy and paste it in. We're going to take the same random forest model, fit RF, and we're going to make the predictions on the data frame right here inside of our reactive. Again, setting the type to probability, so nothing new here. And then all of this is exactly the same as well. We're going to take those predicted values, we're going to turn them into a data frame, and then we're going to pivot it longer so we have a penguin type and a probability, and that's going to output this data frame that now is reactive based on the user inputs. And we're able to take that now, the user specified inputs, and we're able to convert that into our output, which is the bar plot. And so we use the render plot function with the curly braces there. And we're saying dat. Now remember, if you're working in Shiny and you're working with reactivity, it's not a set data frame. It's an interactive data frame. So you kind of call it like a function. So dat is what we named it, and we give it the little parentheses there to say, like, hey, FYI, the user is going to be doing stuff that's going to change this data frame every now and again. So after that, and then the pipe, everything else is our standard ggplot, standard fare, right? So we take ggplot, we're saying, okay, on the x-axis, I want to put the probability, and the y-axis, I want to put the penguin type. So this is going to be a horizontal box plot, a bar plot, sorry. You could do it vertical if you wanted. I just selected it like this. We're going to use our geom call function, which is a column plot. We want to fill the columns as blue and make them slightly opaque with the alpha. And then the outer edges are going to be black. So they're going to be very defined columns. I wanted to label the percentages right on the bar plot so that the user could see exactly what the value was and didn't have to try and look at the axis scale and figure it out. So for that, we label scales, percent, and the probability. And the reason why we do this is because, remember, the probability in our predicted data frame is as a numeric value between 0 and 1. So it's like 0.62. We want that to say 62%. So we use the scales package and the percent function to say, hey, take that value between 0 and 1, multiply it by 100, and put a little percentage sign after it.
Yep, and then round it to...
And round it to one significant digit.
Yep.
Which I think you could specify inside of that percent function if you wanted more.
Accuracy.
Decimal mark at the bottom there, I think. Or
no, it's accuracy.
Oh, is it accuracy? Okay.
Yeah. So now it would do it to the 3 decimal places if we wanted.
Oh, I see. Okay, there you go.
Yeah. I don't think we want to do that, though.
No. Size is 5, so I'm going to pre-specify the size of those labels. We're going to put the x-axis. It also makes it nice for the user to change the x-axis label from a value between 0 and 1 and actually just turn it into something usable, like percent. So scale percent. The theme, I'm going to set the theme of the plot to theme BW, theme black, white. We're going to put labels in there, probability, penguin on the x-axis and penguin species on the y-axis so that they're clearly defined. And we're going to theme up those probabilities as axis, text, and title. We probably could have done one other thing here, which would be to set the x limits between 0 and 1, because I think R will always factor, ggplot rather, will always factor between the highest value. So somewhere in there, we probably want to do C. I think you got to put a concatenate.
Do we?
Oh, maybe not. For some reason, I thought it. Off the top of my head, I feel like it was. But...
2 numeric values.
Oh,
specifying lower left and upper right.
Okay, so we should be
set right here.
Should be good there.
Oh,
okay. No, plus sign. And then one other thing I did here that we haven't done before in any of our Shiny apps is outside of the curly braces, I'm going to explicitly tell Shiny how big and wide I want this plot to be. If I don't do that, it's just going to auto it. So what I want to do is I want to make sure that Shiny knows, hey, I want it to be this height and this width, and you can toy around with that depending on the plot that you're using. Exactly.
Super wide.
Super wide. So that is our that's the guts of the server, and we're literally done. We're ready to run the UI, the server, and
here, let me open it up in the browser so it looks a little bit nicer.
Big. Okay.
There we go.
So now you're going to see as the user changes and slides around on the user interface there. Yeah, we just start to like move the probabilities. Oh, so like that one, maybe it's not sure. Is it a chinstrap or an Adelie, right?
See if we can get them to be 50%.
A little more uncertainty. There. Oh, you had it.
There we go.
That's probably the closest you're gonna get, isn't it?
Watch me get it closer.
Oh.
There we go. All
there
right.
you go. Now. So that's pretty cool. It's a pretty cool way that you could kind of build interactive models into your Shiny app and allow the user, the end user, maybe it's like a business project or a sports project or something like that. Allow the end user to dial up different inputs and see how that changes the potential output. Mm-hmm. And then maybe make decisions based on that.
Yeah, people love explainability in their models.
Yeah.
People tend to not take, some people will not take your word for, no, this is the answer. They want to see, oh, well, if I move this much,
right,
what is the impact on that? Because they won't just take your word, for every $100,000 we spend on this thing, we're going to get this out of it, and it's therefore not worth it. Or, but if we do this and this with their powers combined, that gets us a ton of value.
You know what the interesting thing with this is that look at our x-axis. It didn't. The scales didn't change it.
Because I said it. Because we said. You mean?
No, they're not percentage though.
Yeah.
I think it's because the xlim is taking place maybe before the scales x continuous. I bet that's what it is.
Yep.
Yeah, it's the location.
Scale for x is already present. Adding another scale will replace the existing scale.
So you need xlim up above scales continuous.
Would that do it? Well, let's see.
I think this does it. Let's see.
Well, let's reload app. Open in browser, because browser is so much nicer.
There we go. Oh, but now it's not
it's now going to ignore it.
I think it has to. You know what? The scales x continuous inside of that function, you can specify the limits. That's what it is. So in there, you're going to do limits equals c01, and then get rid of the xlim. And now
there we go. With our powers combined.
Yeah, we should be able to have a. We should be able to have a cool.
Open
we don't
browser.
get any error this time.
There we go.
That's it. Now we got it.
There we can do it.
Live problem solving here, folks.
Nothing but the best here at TidyX.
Yeah, right? Cool.
But this was a lot of fun to put together. Hopefully it is of value and helps you convince your stakeholders of some important task that you've been working on and getting that done.
Yeah.
All right.
Awesome.
Well, thank you so much for joining us today. We always have a great time with y'all at TidyX. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. You can find me on Twitter at OSPPatrick, and you can tweet the both of us at tidy_explained, or email us if you prefer, tidy.explained@gmail, or comment on the YouTube page, or as we explained in the start of the episode, go ahead and drop an issue in on things that you might want to see, or things that you have questions about, or excitement around some of our own ideas that we're going to put into our our own issues as well, as we
Yes.
kind of keep a running tally of things that we might want to work on in the future.
Exactly. We'll provide a link in the video, so definitely check that out. And thank you so much for joining us, and keep on exploring your world.